So in this video, we are going to talk about two types of graphs when we think about network diagrams. Now, one is a connected graph and the other is an isomorphic graph. Now, we said that a graph is connected if every vertex in the graph is accessible from every other vertex in the graph along a path formed by the edges of the graph. So all of our vertices basically have to be connected. If we have any disconnections and can't make a path from one to the other or to all of them, this will not be a connected graph. Now, when we talk about isomorphic graphs, isomorphic is just another word for equivalent. Now, we've talked about equivalent a lot in other contexts. Think about an equivalent fraction, right? Half and 2/4 are two equivalent fractions. They're a different way of communicating the same thing. Now, in terms of these graphs, two graphs are isomorphic, if they have the same number of edges and vertices, and the corresponding vertices have the same degree and the edges connect to the same vertices. So it's essentially just saying that it's a different way to communicate the same information when we talk about a graph. So the graph has all of the other things in common, so same number of edges and vertices, and the corresponding vertices have the same degree and the edges connect to the same vertices. Now, just to practice this, we're going to look at this example, which is saying which of the following graphs is not isomorphic to the other three graphs. So we're essentially just saying which one is unlike the others. Now, what we're going to do, we are first just going to see if we have the same number of vertices. Now, all of these have A, B, C, D, and E. That's cool. Now we have to basically see if they have the same number of edges, or we can think about the vertices having the same degree. Now, looking at all of these vertices, A, for example, has a degree of 3 here. A has a degree of 3 in the second graph. A has a degree of 3 in the third graph. And A has a degree of 3 in the fourth graph. So we can rule out basically A. We look at the next one. Vertex B has a degree of 3. Here it has a degree of 2, okay? So alarm bells are ringing here. Here it has a degree of 3, and here it has a degree of 3 as well. So we can see with this second one, this one is not isomorphic. So graph 2 is not isomorphic. We can also see as well, one other difference, that these, C has a degree of 2, C has a degree of 2 in this one, graph 3, and C has a degree of 2 in graph 4. But once again, in graph 2, C has a degree of 3. So all of these other ones, 1, 3, and 4, are equivalent, but 2 is not. So we say it is not isomorphic. Now, looking at example 2, because this entire video is talking about our graphs basically drawing network diagrams and essentially trying to make these out of different bits of information. Here it's saying that a group of 4 students worked in pairs on 4 different problems. The table below shows the problem number and the 2 students who found the correct solution to that problem. And we want to construct a network diagram to represent the table. Now, we have all of our problems here. We have the students who solved the problem. Now, if we wanted to draw this as a network diagram, the vertices that we're going to choose are going to be the students. That makes sense, right? Because all of the different students are the different points. They're the vertices on our network diagram. So let's just say A, B, C, and D. Now, it's saying what will be an edge in the network diagram. Now, the edge in this network diagram is going to be the other student who they were able to solve the problem with. So, other student who they solved the problem with. Let's actually fix this up. I'll make the writing a little bit smaller. Let's simplify it. Let's just say problem solved. So if they were able to solve a problem, we are going to draw an edge between those 2 students. Now, we want to draw a network diagram to represent the information in the table. So we're told that Darcy and Bo solved a problem. So we're going to draw a line, an edge to connect these two. We know that Alyssa and Bo solved the problem, so A is going to connect to B. We know that Alyssa and Claire solved a problem. Now, just so we're not crisscrossing along here, I'm just going to connect it like this. You don't have to do it this way, but this is just a way to draw it. So I'm connecting A to C. And we have that Darcy and Claire solved a problem. So we're going to connect these two. Okay, so this is one way to do it. Now, part D is saying draw an isomorphic graph here. Just to make this a bit more obviously different, let's draw it like this. So A is going to connect to C, and D is going to connect to C as well. Now, we want to draw an isomorphic graph. Now, drawing an isomorphic graph, let's do this at the bottom down here. So we have Darcy and Bo have solved one together. So let's go Darcy, Bo, next to each other. And let's do A and C. So Darcy and Bo solved one. Alyssa and Bo solved one. Alyssa and Claire solved one. And Darcy and Claire solved one. So this is an isomorphic graph. It's showing the exact same information, but it is presenting it in a different way. They are equivalent, right? They're two different ways of showing the same thing. Now, it's saying in part E, which students have not been able to solve a problem together? This question is basically asking us which two are not connected. So we can see here that Claire and Bo could not solve a problem together. So C and B. Claire and Bo couldn't, and A and D couldn't. Alyssa and Darcy couldn't. A and D. So we have here our combinations that didn't work. So remember, the problem solved is the edge on our network diagram. So if there's no edge connecting D and A and no edge connecting C and B, those are the students that weren't able to solve a problem together. Now, one more example. We're going to really practice drawing up a network diagram. Now, this is that example I gave in the very first video here, a social network. We're talking about basically friends that are connected to one another. Okay, so we're going to basically draw up this social network given these 3 dot points that they've told us. Now, it's saying that Lara is friends with Millie. Let's make these straight lines. I'll do it in a different color. Lara is friends with Millie. Friends with Bonnie. Friends with Chris. Gabriel. And Toby. Okay, so that's the first one done. Okay, now we know that Millie is friends with Lara. We already know that. We have a connection, so we don't have to draw up this edge again. That would be redundant. We already have this connecting bit there, so we don't really want to double up. Millie's also friends with Eden. And Millie is friends with Zach. So we have this part here. That's the second part done. And now the third. We know that Toby is friends with Lara. We already have that. He's friends with Isabel. He's friends with Rose. And Toby is friends with Chris as well. We'll draw this one here. Okay, so all of these now have been accounted for. Just for this last one, let's actually get rid of this shape feature just so you can see this a bit nicer. Toby is connected with Chris too. So we have our network diagram. It's finished. Now, it's saying, what do the edges of the network diagram represent? So the edges here represent the friendship. So the edge represents who the person is friends with. We have the people as our vertices. The edge is the people they are friends with. Now, all of these are connected, okay? There's not one that's left out. So you can make a path basically through each of these different vertices. So we can say the diagram, yes, it is connected. If there was, say, one extra person on the end here, let's say this was, I don't know, Adam, this would not be a connected graph. But because everyone is accounted for, there's a way to connect everyone, all the edges connect to different people. We say that the diagram is connected. That brings us to the end of the video. Thank you so much for watching.